This is R.D. Sharma solution, class 12th, chapter 11, differentiation. Exercise is 11.4. Now, here in this exercise, we will have multiple dy by dx. So, we will combine all the dy by dx, keep it on the left hand side. Whatever comes will be on the right hand side, will be the answer. Okay. So, we'll start with a very moderately easy question, and then we will see that there are questions which needs much more effort than this one. So xy is equal to c square. So just differentiate both the sides. X, because it is with respect to x, so x divided by dx, then y d by dx of x. I am applying the product rule, and then d by dx of c square. C square is a constant, so d by dx will be 0. D by dx of x is going to be 1. Okay, basically nx to the power n minus 1. So it will be the x to the power n is nx to the power n minus 1. When you differentiate this, it is going to be 1 only. This is 1. So we have y here, x dy by dx plus y equals 0. Now we have to find out the dy by dx. So we have dy by dx, keep on the left hand side, and other things you have to keep it on the right hand side. So y will go minus y on the right hand side, x you can divide both sides. So dy by dx is negative y by x. Dy by dx of this one, so we have y cube minus 3x y square, and this is equal to x cube plus 3x square y. So what is this y cube? Differentiation of y cube is 3y square, because it is not x, please remember. If it is x, then it will be simply 3x square. Since it is not x square, because we are deriving with respect to x. So this y cube is going to be 3y square, and then dy by dx. We have to do the differentiation of y also. So 3y square. Then we have dy by dx. Let us just write it. Okay. Then we have this minus 3. So xy square, let us do it separately. And x square y also will do it separately. So we have xy square. So x d by dx of y square plus y square d by dx of x. So x, this is going to be 2y, and then dy by dx. Plus y square dy by dx of x is going to be 1, which I told you in the previous question. So finally what do you get? You get 2xy dy by dx plus y square. This I hope you got the idea. X square y also will do it separately, but x cube is simply 3x square. Now 3, whatever comes, I am going to put it here. So x square y, x square dy by dx, I am applying the product rule, so plus y, x square will be simply 2x. So what do we get? 2xy plus x square dy by dx, that you can write. So this we are going to replace in place of this square bracket, 2xy plus x square dy by dx. Okay. Now let us multiply, and as I said, the dy by dx, these are 3 dy by dx. So we'll take all these dy by dx on one side. So 3y square, this is dy by dx. Let us multiply this, 6xy dy by dx. Then we have minus 3y square. On the right we get 3x square plus 3 to the 6, 6xy plus multiply 3 inside, it will be 3x square dy by dx. So as I said, this term and this term, will take them on one side. So 2 are on the left hand side, 1 will bring it here. So let us do it here. 3y square dy by dx minus 6xy dy by dx, and now minus 3x square dy by dx. On the right, it will be 3x square plus 6xy was already there, and then plus 3y square. 3y square we have taken and put it on the right hand side, 3y square. Now take this dy by dx common. So what do we get? Dy by dx, we have 3y square minus 6xy minus 3x square. Alright, we have 3x square plus 6xy plus 3y square. Now you see there is 3 common. Everywhere 3 is common. So you can take 3 common. Once you take 3 common, you'll see there will be a square formula. If you take 3 common here, x square plus xy, twice xy plus y square. So x square plus y square plus twice xy. And this is the formula of x plus y whole square. X plus y whole square is x square plus y square plus 2xy. So 3x plus y whole square divided by, if you take 3 common from here also, y squared minus 2xy minus x square in the denominator. 3 y square minus 2xy minus x square. 3 is also there. So 3 you can cancel. Numerator, denominator, 3 gets cancelled. So final answer is what we just got. This is your final answer. Okay. Find dy by dx in the following case. So x raised 2 by 3 plus y raised 2 by 3 equals a raised 2 by 3. So same thing here. Dy by dx on one side, other thing on the right hand side. So dy by dx of x to the power 2 by 3, then y to the raised 2 by 3 and a raised 2 by 3. So 2 by 3 and x to the power n minus 1 I am applying. 2 by 3 x to the power 2 by 3 minus 1 plus this is 2 by 3 y to the power 2 by 3 minus 1, and since it is y, we have to put dy by dx. Okay, is equal to, now a is a constant, so differentiation will be 0. 2 by 3 minus 1 is what? 2 minus 3 by 3 minus 1 by 3 it is. So it is 2 by 3 x raised minus 1 by 3 plus 2 by 3 y raised minus 1 by 3 dy by dx equals 0. Now taking this on the right hand side, 2 by 3 y raised minus 1 by 3 dy by dx is equal to negative of 2 by 3 x to the power minus 1 by 3. Please remember it is negative because we are taking it on the right hand side. Now 2 by 3 can cancel. Dy by dx will be x to the power minus 1 by 3 divided by y to the power minus 1 by 3, and there will be a negative. So you can write it as x by y to the power minus 1 by 3, and then you can take the reciprocal so that you get rid of a negative sign. So it will be y by x 1 by 3 negative. Okay, this is your final answer here. Dy by dx, this is the case. Now we have a log here. Same thing we have to do. Everything will remain same because the only thing is dy by dx on one side, others on right hand side, and that is going to be your answer. So we have, let us differentiate it here only. 4x differentiation is what? 4. 3y is 3 dy by dx, and this is going to be equal to log. Log x, log anything is 1 by that thing. So 1 by 4x minus 3y. By chain rule, we have to differentiate 4x minus 3y. So 4 dy by dx of x is 1 minus 3 dy by dx. Okay. Now, so dy by dx on one side, others on other side. So let us see how we can achieve this. Now it is just algebra. Just multiplication, taking left and right hand side. That is the only thing you have to do. Basic thing we have already done. So 3 dy by dx on the left hand side. Now I am multiplying this and now bringing it on the left hand side. So I am bringing this, I am multiplying this 4 into 1 by 4x minus 3y minus 3 into dy by dx divided by 4x minus 3y. This I am bringing on the left hand side. It will be plus 3 dy by dx and 4x minus 3y in the denominator. On right hand side, it will be 4 by 4x minus 3y, and this is minus 4. Okay, now dy by dx, you can take common and you can just resolve this so that you get the simplified version. So dy by dx, 3 is already there, so you can take it out, and 4 is also there on the right hand side. So 1 plus 4x minus 3y is equal to, now you can take 4 common if you want, 1 by 4x minus 3y minus 1. Now you can just solve this. 1 minus 4x minus minus is plus, so 1 minus 4x plus 3y divided by 4x minus 3y. So on right you get 1 minus 4x plus 3y by 4x minus 3y. This is what I was telling you. 4 is already there, multiply. 4 we have already taken common. Alright. And what is remaining here? 4 into 1 minus 4x plus 3y. And this is 4x minus 3y in the denominator. Now let us do this one also. So it will be 4x minus 3y plus 1 divided by 4x minus 3y. 3 dy by dx. Right hand side you have this one. So you can cancel these two. So 3 will bring it here. Dy by dx is 4 by 3. 1 minus 4x plus 3y. And denominator, this will be the denominator. 4x minus 3y plus 1. This is your final answer. Just one step, and other things are simply algebra. Multiplication, bring it here and there, that's it. Now dy by dx of this x square by a square plus y square by b square equals 1. So this you can just skip if you want, because this is quite easy. But those who wants to understand, x square differentiation, 1 by a square is constant, so it will be just like that. X square is twice of x. So a square twice of x plus y square is 2y and b square will remain like that. 2y, then dy by dx, because you are differentiating y now. Dy by dx is equal to 1 is 0. Differentiation of 1 is 0. So you have to differentiate everything. And then dy by dx on one side, others all on the right hand side. So you have 2y by b square, dy by dx on one side, and equals 2x by a square, that is negative of this. Negative 2x by a square on the other side. So dy by dx is 2 you can cancel, minus x by a square, and this b square by y will go like this. Will be reciprocal on right hand side. This is your final answer. Find dy by dx in the following case: x5 plus y5 equals 5xy. So 5x raised 5 is 5x4. y5 is 5 by 4. dy by dx. So this is for x, this is for y, and dy by dx we have to find out. So this 5 by 4 will be there, but dy by dx will be there. Then 5 xy, x dy by dx, I am applying the product rule, x dy by dx plus y d by dx of x, that is going to be 1. Okay, you know all of this. And then we have dy by dx, bring it on one side. So 5 you can cancel this, all these 5 are there. You can take 5 common from here and cancel this out. And bring this dy by dx on one side. So y to the power 4 dy by dx, this I am taking, this is minus x dy by dx equals y and minus x to the power 4. And then you can bring, I am just changing the positions so that I get dy by dx here. Now taking common, y to the power minus x equals y minus x to the power 4. Now bring it down, it will be y to the power 4 minus x. So this is your final result. Alright. Next one is also like that. So again, you can just try it out. But for the sake of completion, I am going to do it. So x plus y, consider it to be some x or y. Just assume it to be x to the power n. So it will be n x to the power n minus 1 when you differentiate it. So twice x to the power of y 2 minus 1, that is x to the power y. And dy dx of x and y, x plus y will also be there, x will be 1, then plus dy by dx. This is just simply the chain rule. Now 2a, what is xy? We have done in the previous question, x dy by dx plus y, d by dx of x is 1 only. So x dy by dx plus y. So let us write it here, x dy by dx plus y. Okay. Now this 2 you can cancel. Now multiply inside. So x plus y I am multiplying inside. Then x plus y into dy by dx, then is equal to a into x into dy by dx, and then we have ay plus ay. Again the same thing. Bring this here and this one on the right hand side. So x plus y dy by dx minus ax dy by dx is equal to ay minus x minus y. Ay minus x minus y. Now take dy by dx common from here. So dy by dx x plus y minus ax equals ay minus x minus y. Now bring it down. This is the denominator, x plus y minus ax. This is dy by dx. That is your final answer. We have to differentiate and we have to find out dy by dx. The whole idea is taking dy by dx on one side and others on right hand side. So the solution I have already given, those who want to understand. So I am differentiating this now. So whatever content is there the power of n, that content to the power n minus 1 is the normal differentiation. That is what we do. So twice of x square plus y square to the power 2 minus 1, that is, it will remain like that only. And then we have to differentiate the right hand side, but before that we have to differentiate x square plus y square also. So x square will be 2x plus 2y, y square is 2y, and then dy by dx. So we have to write like this, 2x plus 2y dy by dx. Alright, on the right it is x into y. So we are taking a differentiation here, dy by dx. So xy differentiation will be x dy by dx plus y, and dy by dx of x is 1 only. So let me write it here, x dy by dx plus y. As already you know, we have to take dy by dx on one side and others on the other side. So let us multiply properly. When we multiply we get 4, x is already there, x square plus y square, this is the first one. Then we multiply it again inside, 2 into 2 is 4, and then y, x square plus y square dy by dx. Now we have first dy by dx here. On the right hand side, I am just rechecking because slight mistake can give you a wrong answer. X dy by dx plus y. Now bring this dy by dx, which is on the right, to the left, and this 4x x square plus y square to the right. So we have 4y x square plus y square dy by dx, and this minus x dy by dx is equal to y minus 4x x square plus y square. Now take this common, dy by dx, just take it common. So we have 4y x square plus y square minus x. On the left and right we have y minus, then see, you can take the negative common on both the sides just to match the answer which is given in the book. So I am taking negative both sides, so the position of the values will change. So 4x into x square plus y square minus y here divided by this also, x minus 4y into x square plus y square. So we have x minus 4y x square plus y square. This is dy by dx. Alright, this is your final answer. find dy by dx in the following case. Tan inverse x square plus y square is equal to a. So tan inverse differentiation we already know. This is 1 by 1 plus whatever content is there, that's square. So d by dx of tan inverse 1 by 1 plus whatever is the content, x square plus y square, in this case x square plus y square whole square. Then we have to differentiate x square plus y square also, because we will be using the chain rule. We have to apply the chain rule. So x square is 2x, y square is 2y, and then dy by dx also for y. So 2x plus 2y dy by dx is equal to, a is a constant, so it will be 0. Okay. Now what happens here is, take the cross multiplication. So this will be 1 plus x square plus y square whole square. This is going to be multiplied to 0. Okay, or you can say that we can multiply both sides by, what? 1 plus x square plus y square whole square. This we can do. So when we multiply this, it will be, this whole content will be a goner. So we will be having 2x plus 2y divided by dx. So 2y divided by dx equals to negative 2x. 2 gets cancelled. Y divided by dx is equal to negative x. And y you can bring it down. So dy by dx is equal to minus x by y. This is your answer. Now find dy by dx in the following case. Now we have e raised to the power something, also log x by y. So what do you get in e? What do you get in log? Same thing what we have been doing. E to the power something will remain as e to the power something. Log will be 1 by that thing. So e raised x minus y, and then we have to differentiate x minus y. So x will be 1 and y will be dy by dx. So this will be 1 minus dy by dx. On the right hand side, it is log x by y. So log is 1 by that content. That is 1 by x by y. So y will go up. This goes y by x. So y by x into differentiation of x by y. What is x by y? We have to differentiate now x by y. We'll use the quotient rule here. So we have y square here, and this y goes here, d by dx of x. D by dx of x is 1 only, I'm not writing it, minus x into dy by dx. Okay. So this is, what do we get? Everything is depending upon dy by dx. Wherever it is, bring it out one side. Alright. So let us see how we can do this. E raise x minus y, and multiplying inside, okay, and minus e raise x minus y into dy by dx equals to, now one y we can cancel before multiplying the outside with inside. One y you can cancel. This you get y by y into x. This is first. 1 y I've already eliminated, okay. Then you have x dy by dx, y is already there in the denominator, and x, this one, x dy by dx divided by y. So what do we get? This y gets cancelled, and this will give you 1 by x minus x gets cancelled, you get 1 by y dy by dx. Here on the left hand side we have e to the power x minus y minus e raise x minus 1 dy by dx. This is all algebra. Differentiation we have already done. It is just dy by dx on one side and others on right hand side. So I am taking this one here and this one there. So e to the power x minus 1 by x I have taken here, minus, this is equal to So dy by dx I'm already taking common. So this will go on the right hand side, will be a plus. So e raised x minus y dy by dx, and you have this so e to the power x minus y minus 1 by y, because dy by dx I have already taken common. Now dy by dx will be equal to e raised x minus y minus 1 by x divided by e raised x minus y minus 1 by y. Okay, so this is your answer, but you can simplify it more. Assume it to be division by 1. So x into e raised x minus y and minus 1 divided by x. Here you have y into e raised x minus y minus 1 divided by y. The denominator will go up, so it will be inverted. So y by x by y will become y by x, and this we have x into e to the power x minus y minus 1. So this is y x by y and e raised x minus y minus 1 divided by e raised x minus y minus 1. So let us take this. This is your final answer. Okay. Main thing is all dy by dx. Okay. Everything you have to take on the right. Only the left will be dy by dx. So we have to find out the dy by dx. So these are all routine questions now. All of them you know already. So if you want to skip, you can skip. Sin xy is cos xy. What is xy? X into dy by dx plus y. Okay. So I am writing x dy by dx plus y. Okay. Sin xy is cos xy, x dy by dx plus y. Now we have to this I'm just rechecking. And then we have plus cos xy will be minus sin. So I am just changing the sign. Minus sin x plus y. And x plus y will be x. X will be 1 and y will be dy by dx. And this is 1 plus dy by dx. And 1, of course, the differentiation will be 0. Okay. Now multiply. Just multiply and just take this dy by dx on one side. So I'm just multiplying. This is just simple algebra, okay? X cos xy dy by dx plus y cos xy minus sin x plus y minus sin x plus y into dy by dx. Alright? Equals 0. So take the dy by dx one side. And dy by dx I am taking common. So it will be x cos xy and minus, this is minus sin x plus y into dy by dx. So dy by dx already common. It will be sin x plus y. Whatever is here, take it on the right hand side. I am taking it on the right hand side. So we have sin, just change the sign and write it. Sin x plus y and minus y cos xy. Alright? Sin x plus y minus y cos xy. Now, this on the left hand side, take it in the denominator, x cos xy minus sin x plus y. So whatever I am saying, in the previous question also we have, I have told you that all these steps have to be done one by one. I am doing it whenever I am comfortable with, just to let you know how it is being done. But every step which is given in the answer, which I show you always, is what you have to do one by one. Okay. Now next one is, So this is dy by dx again. Now there are two things which I would like to emphasize here before we go ahead, is that you can easily solve this question without even putting any substitute. So normal substitution, normal differentiation, and then substitution. They are two different things. I'm sure that you can try without putting anything. The answer will come. Same answer will come. But there is another way which I am supposed to tell you, because this will take a certain effort. So I'm telling you the way of solution when you are putting some certain substitute. For example, x as sin A, y as sin B. Now I'll see how it is being done. Substitution method I'm going to tell you. So you have sin A, x as sin A, y as sin B. Okay. So the question will be, why you are taking sin A and sin B? Why are you not taking cos A and cos B? You will just see. So we are 1 minus sin square A will be cos square A, and under root of cos will be cos only. Similarly, on the right hand, y will be sin B, same thing. But right hand side it will be x minus y, so it will be sin A minus sin B, and we'll get something out of it so that we can get cancellation. I'll just show you. So we have x equals, you can take anything, sin theta, sin whichever you want. I'm taking sin A. So x is equal to sin A, y is equal to sin B. So this is under root 1 minus sin square A plus under root 1 minus sin square B. Now this is A into x minus y. What is x? Sin A. What is y? Sin B. Under root 1 minus sin square will be 1 minus sin square is cos square A. Under root of cos square A will be cos. So this will be cos of A plus this will be cos B. Similarly A into sin A minus sin B. Now bring this cos A plus cos B on one side, and means keep A one side and others on the other side. So cos A plus cos B divided by sin A minus sin B. Okay. Now cos A plus cos B, what do you get? It's 2 cos A plus B by 2 cos A minus B by 2. Okay. So we have cos A plus B by 2 cos A minus B by 2 divided by 2 cos A plus B by 2 and sin A minus B by 2. Alright. Cos gets cancelled, 2 get cancelled. You have cos A minus B by 2 divided by sin A minus B by 2. And what do you get? It is cot A minus B by 2. Cot A minus B by 2. And this is going to be cot A minus B by 2 is equal to A. Now take this 2 I am taking on the left hand side. So A into cot inverse A into A minus B. So twice of cot inverse A will be equal to A minus B. So remember, what was A and B? You cannot write A and B. It has to be with inverse, because A and B you have introduced. It has to be written in the terms of x and y. So it will be sin inverse x minus sin inverse y. So 2 cot inverse A is equal to sin inverse x minus sin inverse y. Now you can differentiate. Because 2 is constant, cot A is constant, it will be 0 differentiation. Sin inverse x differentiation is under root 1 minus x square. Minus is already there. Sin inverse y is 1 by under root 1 minus y square. Okay. So this is y. So you have to introduce dy by dx also. Now take this on the left hand side. So you have 1 by under root 1 minus y square. Dy by dx is equal to 1 by under root 1 minus x square. So 1 minus y square, 1 minus x square. You can just give them the place dy by dx, I mean the proper place. So dy by dx will be equal to under root 1 minus y square by under root 1 minus x square. Okay. So let me tell you again. So if you directly solve it, that's up to you. And you can also solve using what I have just told you. Alright. You can also do in this substitution method also. So this question, we can do it by substitution, we can directly do it. We will come across a question where we will do it directly, but these questions, when we substitute, they become very easy. So what we will do here is, x we will put as sine A. Why? Because it is under root 1 minus x square. Similarly, we will put y as sine B. What is the benefit? When we put y as sine B, the sine B under root 1 minus x square, that is 1 minus sine square A. And here we will have plus x is sine A under root 1 minus y square, that is sine square B. So this is equal to 1. So let us resolve it and then we'll do the actual differentiation. 1 minus sine square A is cos square A, under root cos square A is cos A. So ultimately this is going to be cos A. So sine B cos A plus this is sine B, sine A, and 1 minus sine square B is cos square B, under root cos square B is cos. So cos B it is equal to 1. So we have sine B cos A, or you can call it as cos A sine B plus cos B sine A, like that. In any ways, it is going to be sine A plus B. So A plus B, B plus A, whichever way you write, it is equal to 1. So when we differentiate it, what do we do? See, we cannot differentiate it right now. A and B we have by ourselves included, or you can say evolved. So we have to convert this A in terms of x. So A will be sine inverse x and B will be sine inverse y. And that is what we are going to put. Before that, we have to take this sign on other side. So A plus B is equal to sine inverse of 1. Sine inverse of 1 is what? It is 90 degree. Pi by 2 you can write. And in place of A and B, we can replace it by sine inverse x plus sine inverse y. So sine inverse x plus sine inverse y is equal to pi by 2. Now the differentiation d by dx on either side. Alright. So this is constant, so it will be 0 on the right hand side. D by dx of 1 by sine inverse x is 1 by under root 1 minus x square. D by dx of sine inverse y is under root 1 minus y square. And since it is y, we have to include dy by dx also. Taking this on the right hand side, so dy by dx under root 1 minus y square is going to be equal to negative of 1 by under root 1 minus x square. That is, we have taken it on the right hand side. This denominator goes to the numerator, so under root 1 minus y square it will be. So this is your final answer. This is what we have to prove. Directly also, if you try, you will get the same answer. xy is equal to 1. We have to prove that dy by dx plus y square is equal to 0. So xy is equal to 1. Differentiate x. I am applying the product rule. X divided by dx plus y d by dx of x is 1. I am not writing it. Is equal to 0. D by dx of constant is always 0. Now dy by dx plus y square it is. So we have to eliminate x. How can we eliminate x? See, xy is equal to 1. So we can always write x is equal to 1 by y and y is equal to 1 by x. So this x we can replace it by 1 by y because we only need y. So dy by dx it is, x is, let us take y on the right hand side. X I am replacing it by 1 by y and y square it is. So this x, as I said, 1 by y will be better, so that we get y on the numerator, and there are two new y's, so we'll get a y square. So minus y square it is, dy by dx. Now let us bring this minus y square on this side, so dy by dx plus y square is equal to 1. Okay. So this is equal to the result. xy square is equal to 1. So xy square equals to 1. And for the reference, if you are able to solve by yourself, or you have to do some homework, this is the solution. But how to solve it? Xy square equals 1. Let us understand. So I'm applying the product rule. X dy by dx of y square plus y square dy by dx of x is equal to dy by dx of 1, which is going to be 0. So we have x, y square is 2y dy by dx plus y square dy by dx of x is 1. And this is going to be 0. So y square I am taking it here, dy by dx, everything on the right, that is. So 2xy dy by dx will be equal to negative y square, and 1y you can cancel. Dy by dx will be negative y by twice of x. Okay. Now you see the answer is only talking about y. There is no x. So from the initial thing being given, x will be equal to 1 by y square. Let us put it here. X is 1 by y square. So minus y by twice of 1 by y square. And this goes up. So it will be minus y cube by 2. And 2, there is no need to bring 2 on the right hand side. We have brought it. So we'll take again back it to the left hand side. So twice of dy by dx is equal to negative of y cube. So 2 dy by dx is negative y cube. Now negative y cube on the left hand side. When we bring it, it is going to be positive y cube. So 2 dy by dx plus y cube is equal to 0. That is the final answer. So here it's better because we don't have some 1 minus y square or 1 minus x square stuff. It's better to solve it the way it is. In the previous questions, I encourage you to solve it using sine and cos, that is by substitution. So what we'll do here is x under root 1 plus y. This we are going to bring it or transfer it on the right hand side. So it will be negative y under root 1 plus x. Now let us square both the sides. And we have to get rid of the root basically. So let us square them. It will be x square, then 1 plus y. And then we have minus y square is y square. This is 1 plus x. And then we have this. Now let us multiply now. When we multiply, we'll get certain thing. And then we'll start the differentiation. Right now we are not differentiating it. The differentiation will be done when we have simplified it. Alright. So this is going to be x square and 1 x square y, then y square plus y square y. And this x square minus y square we can have a formula. So let us bring this y square on the left hand side and x square y on the right hand side. X square minus y square, we get y square x minus x square y. And this, so we can take xy common from the right hand side. I am just taking the right hand side. So it is going to be y minus xy. X square minus y square will be x minus y, x plus y. A minus b, a plus b. So xy, y minus x. We can cancel x minus y and y minus x, but there will be a negative because let us make it as negative. It will be x minus y. So let us cancel these two out, but there will be a negative. And y, take y on one side and others on right hand side. But still there is y on either side. So we need to manage this thing such that we get only y on one side, other things on the other side. Alright. So we have this minus, I hope you got the idea, minus xy equals x plus y, and we have to find y. So let us take y on one side. So this y goes here, x will be y plus xy, and because it was already negative 1, remember. So we have x equals, this negative is already there, okay. So we have y equals negative x by 1 plus x. Now this is what we wanted. Y on one side, x on other side. Now we will differentiate. And this negative x, negative sign, I am going to deal it later. I will only differentiate x by 1 plus x. And that is going through the quotient rule. Alright. So negative x by 1 plus x. So let us differentiate d by dx, d by dx. So dy by dx will be equal to negative I am going to take later, x by 1 plus x. So quotient rule we are going to follow. This is 1 plus x whole square. Then when 1 plus x d by dx of x, that is going to be 1. I am not writing it now. Minus. Then we have x d by dx of 1 plus x. So it will be 1 plus x is 0. This is 1. So it will be 1 only. So what do we get? 1 plus x minus x. So x can be cancelled. Now 1 was there. As I said, negative I have not used. Now I will use minus 1 by 1 plus x whole square. This is d by dx. Now cross multiplication, 1 plus x square into dy by dx, and plus 1 when it comes to the left hand side, plus 1 equals 0. This is what we need to prove. Alright. Next is we have a log on one side, tan inverse on other side, and for those who just want to do it by themselves, there is a reference being given. And those who want to understand, let us see how it will be done. So it's a very straightforward question. If you know the differentiation of log and tan inverse, it's very straightforward. Okay. But one thing is log x square plus y square, under root can be written as half. Under root is to the power half. So whenever we have log a to the power b like this, b comes in front. So it will be half log x square plus y square. Alright. So that is the only thing we need to do. So half d by dx of log x square plus y square. Then we have tan inverse y by x. So d by dx of tan inverse y by x. Tan inverse of theta. Well, let us do the left side first. Log of content is 1 by that of content, 1 by 2. So it will be x square plus y square in the denominator. X square plus y square differentiation is what? X square is 2x, y square is 2y, and then dy by dx also, because we are not dealing with x, we are dealing with y. So 2x plus 2y dy by dx is equal to, first thing is there are 2's, so you can take 2 common here and cancel it out. You know, it can always be cancelled. And this is equal to, and right hand side, certain things are going to come which can be cancelled from the left hand side. So let us solve this one. First, d by dx of tan inverse or by x, it is going to be 1 by 1 plus y square by x square. Then y by x differentiation also. Y by x differentiation, I am doing it here. It will be using the quotient rule. So x square in the denominator, x here, then dy by dx minus, then we have y d by dx of x is 1. Okay. So this is your final one. So let us do this one also. This is going to be, I am doing it here. 1 by, so x square plus y square by x square. Now this x square I am not writing because it will go in the numerator. So finally this is going to be x square by x square plus y square. And this one also x into dy by dx minus y by x square. Now what do you see here? What was the left hand side? If you remember, it was 1 by x square plus y square and x plus y dy by dx. Now this x square plus y square gets cancelled. This x square gets cancelled from here. Finally what we have achieved is x plus y dy by dx is equal to x dy by dx minus y. Now there is only one thing, which is rearrangement in order to get this solution. So y here means dy by dx on one side, others on other side. So we have x plus y, dy by dx I am taking common, I am bringing it here. This is going to be dy by dx x minus y. So dy by dx will be equal to x plus y by x minus y. And that is what the result says. We need to prove it, and we have proved it. So sec x plus y by x minus y is equal to a. So we have to prove this. And we know the sec inverse, what is the differential, and the best way is to bring this sec on right hand side. What is the benefit of this? So x plus y divided by x minus y. Sec I am bringing it here. So it will be sec inverse A. So when we differentiate it, the right hand side is going to be 0 because it is A. It will be a constant. So we just have to concentrate on the left hand side differentiation. D by dx of both the sides. So simple is, see, x minus y whole square. Now x minus y d by dx of x plus y minus x plus y and d by dx of x minus y. Right hand side absolute 0. X plus y differentiation is what? 1 plus dy by dx. X minus y differentiation is what? 1 minus dy by dx. Okay. So we have this x minus y. Both sides, let us multiply it by x minus y whole square. Both sides left LHS, RHS. Or you can take the cross multiplication. X minus y whole square will be a goner. You can eliminate it. Only the numerator will remain. So x minus y, dy by dx of x plus y will be what? 1 plus dy by dx. And this right hand side, if you can bring, or you can just have a negative. It's up to you. I'm going to bring it on the right hand side and then solve it. X plus y and differentiation of x minus y we have already done. It was 1 minus dy by dx. Okay. So what do we get? So x, let us multiply it. X minus y plus x minus y into dy by dx is equal to x plus y minus x plus y into dy by dx. Now bring dy by dx on one side, the other content on another side. Okay, let us do it. This one. So we have dy by dx, x plus y, and this we are bringing here. So when it goes on the left hand side, it is going to be positive. Plus x plus y. X plus y was already there on the right hand side, and x minus y with a negative we are bringing it on it here. So minus x plus y it will be. X cancelled, so you get a 2y on the right hand side. This we get 2x on the right hand side, left hand side. 2 gets cancelled. Y will go in the denominator. So dy by dx is going to be y by x. That is your final answer. Okay. So the whole idea is to explain. Step by step doing will take, it will be a waste of time for you because there are so many questions you have to do and you have limited time. If tan inverse x square minus y square by x square plus y square is equal to a, we have to prove that dy by dx is this. Now we have a constant here. Better is to take this tan inverse, or here on the right hand side will be tan a, and then to solve it. Or you can take this x square plus y square also along with this tan a. So the differentiation will be quite easy. And we can see that the answer also is indicating to that only. So how do we do this? So the step is tan inverse I am taking on the right hand side, it will be tan a. And then we have x square minus y square here. And then we have x square plus y square in the denominator and it goes here, x square plus y square. Okay. Now what is the use? When we differentiate, this tan a will be considered as a constant. So we don't have to worry about it. We just have to worry about these two. Alright. Now let us differentiate d by dx. This also d by dx. Okay. So this is x square, so it will be 2x. Y square is 2y dy by dx. And then we have tan a, it will be like that only. Then 2x plus 2y and then dy by dx. Okay. Now bring this dy by dx on one side, and whatever comes will on the other side will be the answer. So 2 you can just take common and cancel. It will be removed anyways. And then dy by dx on one side. So this is x minus y dy by dx. And on the right hand side it will be a into x into tan a. X into tan a. and plus tan A into y into dy by dx. Now dy by dx I'm bringing it here so that it becomes plus, and x tan A on the left hand side. So x minus x tan A is equal to, so we have tan A y dy by dx plus y dy by dx. Now take this dy by dx common. What is remaining? You will get y tan A. Oh, y is constant common. So let us take y outside. So it will be only tan A plus 1. So 1 plus tan A you can write. 1 plus tan A. Alright. This is x. You can take x common. 1 minus tan A here. Okay, y. Just bring everything on the other side and dy by dx on one side. So y 1 plus tan A on the right, I brought it in the denominator. So in one step only, I told you many things because writing all these things will take time. But you have to do like this. Main thing is the first step when we are finding the dy by dx, this dy by dx. So how are you going to go about it? That is the main thing. The other thing is just algebra, nothing else. This question, if you see, first is there is no log on the right hand side. This is very important. In most of the question we are doing today, the log and other terms are not there and we have to remove it by what is given. So we are given this xy and then I am using the product rule. So log of x plus y d by dx and then plus log of x plus y and then d by dx of xy, and this is equal to 1. Differentiation of 1 is 0. So we have xy, log x is 1 by x plus y, and then x plus y differentiation. Differentiation of x plus y is going to be x is 1 and this is dy by dx. Then we have, this is the first thing. Now plus log x plus y, and again we will do the xy differentiation, x dy by dx plus y dy by dx of x is 1 only. So we have x dy by dx plus y, x dy by dx plus y. So just write it here, x y plus x dy by dx you can write. So our differentiation is done, but there is no log. There is no log on the right hand side. So we need to get rid of this log. Wherever it is, we have to do something. So what we can do here is first see, there are various ways. The solution which I presented you has a different approach. I will do something different. You may do something different. We need xy into log x plus y. So what I am doing here is xy x plus y 1 plus dy by dx. So this is just hit and trial. I am taking other thing on the right hand side, minus log xy. We have y plus x dy by dx. So what I am going to do is, we know that xy into log xy is 1. So I am myself multiplying xy on both the sides by myself. So this xy I have already multiplied, and if you see here, this xy log x plus y on the right hand side is 1. So you have a negative y plus x dy by dx. Alright. Here we have x square y square divided by xy. Xy we have already included by ourselves. Then 1 plus dy by dx. So now we will try to couple these dy by dx together and then try to bring it on one side and others on other side. So I am multiplying inside. This is the multiplication. X square y square by x plus y multiplied by 1 plus dy by dx will give you this thing. And this is minus y minus x dy by dx. Now bring it here and bring this one here. So what do we get? So x square y square by x plus y plus dy by dx, this is the first thing, plus x dy by dx. This dy by dx terms on the one side, and then we have minus y plus it will be negative only because minus x square y square by x plus y. Now since dy by dx can be taken common, and what do we get? X square y square by x plus y plus x, and this is going to be equal to, let us solve it. I'm just getting rid of negative. I'll use it later. Assume it to be positive one. So we have y xy plus x square plus y square, taking LCM divided by x plus y. So we are multiplying y with x plus y plus x square y square divided by x plus y. This also we can do. Let us do this here. Dy by dx. This is going to be x square plus x square y square plus x into x plus y and divided by x plus y. Now you see here, right hand side, left hand side, x plus y and x plus y are both in the denominator. So you can just cancel these two. Just cancel these two. Here you take x common. When you take x common, dy by dx, x I am taking common. So you have x y square plus x plus y, and right hand side I am taking y common. Please remember, minus I just didn't use. Minus will use just now. Y is outside, I am taking. So we have x plus y plus, and since y already taken common, so y plus x square, y x square. Negative sign now I have written now. And right hand side I am bringing it down, x y square plus x plus y. So this is the answer. Alright. So as I said, there are multiple ways to do it. The whole idea is in this question is to get rid of log, because log is not in the answer. Y is equal to x sine a plus y. Prove that dy by dx is equal to sine square a plus y by sine a plus y minus y cos a plus y. So y is equal to x sine a plus y. And on the right hand side, whatever it is, see, we don't have to remove anything, but there will be a step where we have, because on the right hand side there is no x. In the answer dy by dx, if you see, there is no x on the right hand side. So ultimately we have to convert this x to y by sine a plus y. So y is equal to x sine a plus y. So dy by dx will be equal to x sine is dy by dx of sine a plus y basically. And then we have sine a plus y and dy by dx of x, that is going to be 1. I am leaving it. So x sine is cos. So this is going to be cos a plus y, and differentiation of a and y, a is 0 and y is of course dy by dx. So dy by dx will be here, dy by dx plus, and so this differentiation has been done, and now sine a plus y differentiation will be done. Okay, now this plus sine will be sine a plus y. This remains here, okay, dy by dx. Now bring this dy by dx all on one side. Dy by dx, we get, so 1 minus x cos a plus y. And then on the right hand side, we are getting sine a plus y. Now sine a plus y on the right hand side, and whatever you get in the left hand side, bring it down. So dy by dx is sine a plus y divided by 1 minus x cos a plus y. So now you will think that this is the answer. No, because there is no x on the right hand side, and since we have y equals x sine a plus y, we will use this here. So there is no, as I have been reiterating, there is no x here. So in place of x, we will replace it by y by sine a plus y. Okay, the x will be y divided by sine a plus y. So this is going to be sine a plus y divided by 1 minus, in place of x I am writing y by sine a plus y, cos a plus y. Now you will see cos and sine. You will try to write cot. No. So let us solve the denominator first. So it will be sine a plus y. I am taking the LCM. Sine a plus y minus y into cos a plus y divided by sine a plus y. Now this goes up. This sine a plus y will go up. So it will be sine square a plus y. Denominator will be sine a plus y minus y cos a plus y. And this is the answer. Alright. If x sine a plus y plus sine a cos a plus y is equal to 0, we have to prove that dy by dx is equal to sine square a plus y by sine a. Here also there is no x on the right hand side if you see dy by dx. So first differentiate. The basic thing is to differentiate. So x. So we will apply the product rule. So x d by dx of sine a plus y, and then plus sine a plus y d by dx of x. I am not writing it. It is going to be 1. And then plus sine a is a constant, so you can write just like this. And cos is minus sine a plus y. So I am just changing the sign. This plus is actually minus now, because cos differentiation is minus sine a plus y, and then a plus y differentiation also. A plus y differentiation is what? 1 plus dy by dx. So it will be dy by dx. And this is going to be equal to 0. Now let us take the term with dy by dx. So dy by dx. No, this differentiation we have to do. Let me do it. So x sine a plus y is cos a plus y. And then we have to differentiate a plus y by the chain rule. So a plus y d by dx of a plus y, a is 0, and d by dx of y only will be there. Minus sine a plus y dy by dx. This is all dy by dx term together. And this sine a plus y on the right hand side. So it will be negative sine a plus y. Now take this dy by dx common here. So inside that you will get x cos a plus y minus sine a plus y, and on the right hand side you have minus sine a plus y. Okay. Now bring this in the denominator. So dy by dx will be equal to minus sine a plus y. Now if I want to change the sign, this negative I want to eliminate on the right hand side, I'll just change the positions of this. So it will be sine a plus y, the negative sign. When I'm bringing this total on the right hand side in the denominator, I'll change the positions only. So we can get rid of the negative. But I will replace this x here only, because there is no x on the right hand side. I hope you got the idea. There is no x on the right hand side. So we have x sine a plus y equals minus sine a cos a plus y. So in order to get x, that is going to be minus sine a cos a plus y by sine a plus y. So there is no use of what we have done negative. Anyways, so minus I am removing. So this is sine a and sine a plus y, and since in the place of x I am replacing it by minus sine a cos a plus y by sine a plus y. So minus minus will be plus. So sine a cos a plus y divided by sine a plus y. Okay, and there was cos a plus y was already there. We have just replaced the x. So this cos a plus y will remain like that. Okay. Now let us take the LCM of the denominator. What do you get in the denominator? Because sin a plus y sin, do we get anything common? Yes. We have in the denominator sin a common. So these two sin a and sin a you can take outside. What I am trying to suggest is this sin a and sin a you can take outside from the denominator, and rest thing will leave, and then you will see what you will get, because there will be a sin square plus cos square term coming, and that is going to be 1. So just assume that dy by dx 1 by sin a I have already taken common, and then let us solve this now. Sin a plus y was already there, and now I am taking the LCM here without sin a. So sin square a plus y it will be, and then we have this and plus this cos a y and cos a plus y it is already there, cos square a plus y. Denominator is sin a plus y. Now sin square theta plus cos square theta is going to be what? 1. Sin square plus cos square is going to be 1. So this you can just replace by 1. This sin a plus y goes up. It is going to be sin square a plus y. So numerator will be sin square a plus y. Denominator is sin a. The denominator it is sin a. So dy by dx is sin square a plus y by sin a. And this is what we wanted. This is the final answer. So the whole idea is algebra, proper differentiation, and then just to see what is there or what is not there, just replace it like that. Now this is a very straightforward question. Y is equal to x sin y, and dy by dx we'll find out. So the main thing is dy by dx on one side, others on other side, that will be the answer. So dy by dx is x sin y, d by dx of sin y plus sin y and d by dx of x. Now this is x, sin y will be cos y, and since y is there, so we will have dy by dx also. Then we have this sin y, and d by dx of x is 1 only. So we have this one, sin y. So dy by dx is this. There are 2 dy by dx. Let us bring it here on the left hand side. So dy by dx, and since there is 1, so 1 minus x cos y, which we bought on the left hand side, and is equal to sin y. So dy by dx will be equal to sin y and divided by 1 minus x cos y. And this is what needed to be proved. So this is how you have to write. Now here also this will need some effort, but there will be no putting of something or substituting of something. It's just like any other differentiation. So we will do the differentiation on both the sides. So left hand side I am doing first, y into under root x square plus 1. So we'll use the product rule here. So I am applying product rule. So first we will take y, differentiation of under root x square plus 1. So y d by dx of under root x square plus 1. Then we have under root x square plus 1 here, and then dy by dx. Dy by dx, and this is equal to, we'll do the left side first. So whichever is the under root, it will be always 1 by twice of under root of that content. So it is x square plus 1. Now I'll do the differentiation of x square plus 1. X square is 2x and 1 is 0. So we'll have 2x here. Then we have plus under root x square plus 1 remain like this, and then dy by dx. So 2 you can cancel it out. Finally what do we get? We got xy divided by under root x square plus 1 plus under root x square plus 1 dy by dx. Now on the right hand side we are doing, this is log, d by dx of log is what? 1 by that thing. So 1 by log under root x square plus 1 minus x, then the differentiation of, no, there will be no log. Log differentiation is 1 by that thing. Then we have 1 by twice of under root x square plus 1, which we did just now, minus, and differentiation of this the x square plus 1 also we have to differentiate, so 2x, and minus 1. xy divided by under root x square plus 1. Then we have plus under root x square plus 1 dy by dx, and this is equal to 1 by under root x square plus 1 minus x. So you can cancel this 2 if you want, and then it will be x by under root x square plus 1 and minus 1. Okay, so we have 1 dy by dx only. So others we can manage. All the other things you can bring it here on the other side, and you can just keep this dy by dx here. So 1 by under root x square plus 1 minus x, I am writing the right hand side. Then we have, this is x, whenever we have this, so we have x, I am taking LCM, x minus under root x square plus 1 divided by under root x square plus 1. Okay. Now this we are bringing it on the right hand side. So minus xy divided by under root x square plus 1. So these 2 gets cancelled, and under root x square plus 1. So there are two things. One is under root x square plus 1 you can take common. Alright. And in the first term, if you see under root x square plus 1 minus x, this also you can cancel. This you can cancel out because they are same. And you can take 1 by under root x square plus 1 common. Why I am taking common? Because on the left hand side we have under root x square plus 1 already. Alright. So there is the only difference between this cancellation is the two terms are swapped. So I am bringing a negative outside. X minus under root x square plus 1, I am making it as under root x square plus 1 minus x, then cancelling. So minus is outside. Under root x square plus 1, as I was discussing, I have taken common. So it will be negative. And since we have a 1, so negative 1. And then this xy by under root x square plus 1. Because we have already taken, okay, this under root x square plus 1 common. On left we have under root x square plus 1 dy by dx. So I am multiplying it now. So under root x square plus 1 under root x square plus 1 will be x square plus 1. Dy by dx is already there. We have negative 1, negative xy. Now bring it these two on the left hand side. So this is, when we bring it here, I am just changing it here only, just because of the lack of the area. So plus 1 plus xy, and this is the final answer. Okay, x square plus 1 dy by dx plus 1 plus xy. If sin xy plus y by x is equal to x square minus y square. So here also same thing, just differentiation, bringing dy by dx on one side. So there is no substitution, and there is nothing to be thought of. There is no trick actually. So the answer is what we need in R.D. Sharma's book. So that's what we will try to get. Just they are saying dy by dx find out. So I am doing this one, okay. I am not writing the question again because it is in front of you. I am doing direct differentiation. So sin xy differentiation is cos xy. Now you have to differentiate xy also. So xy will be x dy by dx plus y dy by dx of x. So you will get x dy by dx plus y dy by dx of x is 1. So cos xy into x dy by dx plus y, and then y by x. This y by x is a kind of a quotient rule we will apply. Y by x. So I'll just do it here. I'll do it here. So y by x differentiation will be using the quotient rule. So it will be x square in the denominator. I am differentiating y by x. X dy by dx minus y dy by dx of x is 1 only. So I am not writing it. So final, what will be the result? Plus x dy by dx minus y divided by x square. So we can bring this x square here. Okay. On the right hand side, x square will be equal to 2x minus y square. So y square will be 2y and dy by dx. Okay. Now let us multiply. Properly we'll multiply. On the left hand side there is multiplication, and then we'll take dy by dx on one side, others on the right hand side. I'll try to do it in short steps. The result is already shown to you so that you can see the arrangement. X cos xy dy by dx plus y cos xy, and now this is x. When you multiply 1 by x square inside, so it will be 1 by x square into x dy by dx. Okay, so x cancel, you will get, so you have plus here, x has gone, dy by dx, 1 by x is there. Now minus 1 by x square into y, so minus y by x square. Right hand side 2x minus 2y dy by dx. Now bring this dy by dx term together. Others you can bring, shift it to the other side. So dy by dx. Okay, I'm saying I've already bought this dy by dx minus 2y dy by dx here. So I'm writing it directly. First term will be x cos xy. Second term is plus 1 by x. Third term, when after bringing it on the left hand side, it will be plus 2y dy by dx. Alright, this is dy by dx term. So 2x is on the right hand side, and this y cos xy will go on the right hand side, y cos xy, and this y by x square, negative y by x square, when it goes on the right hand side, it will be plus y by x square. So let us write it here. So we cannot just leave it like that, because there is something with the denominator. 1 by x is there on the left hand side, 1 by y by x square in the right hand side. So let us take the LCM. When you take the LCM, it is x. Now what will be here? Because we have x in the denominator, so you have to multiply it, x square cos y. X already taken, so it will be 1. And since there is no x here, so you have to multiply x here, 2xy dy by dx. Right hand side also same thing. Your x square in the denominator. Since there is only one x, so x square has to be multiplied. And then we have x square to be multiplied. There is no x square term. Here x square you have already taken, so it will be y. Now 1x you can cancel it with x. So there will be 1x remaining. So this dy by dx will be equal to 2x cube minus x square y cos xy, and plus y I have written first. 1 by x is already there, which was left when we cancelled x and x square, and here x square cos xy plus 1 plus 2xy. Okay, this is your dy by dx. This is your final answer. This I tried to match with the book answer. Now tan x plus y plus tan x minus y is equal to 1. Find dy by dx. So this, if you know the differentiation of tan theta or tan x, this question is quite easy. So those who know it, they can just move forward. And those who want to understand, let me solve it. And dy by dx will be like that, the same thing, dy by dx on left hand side, others on right hand side. So tan x plus y will be tan theta or tan x differentiation is sec square x plus y. The differentiation of x plus y will be x will be 1 and y is dy by dx. Then we have plus. Tan is sec square x minus y and differentiation of x minus y. X is 1 and minus dy by dx. This is equal to 0. And simple thing is just multiply inside everything, collect the term with dy by dx on one side and move everything or shift everything on the right hand side. So sec square x plus y, this is multiplied, plus sec square x plus y dy by dx, and then we have plus sec square x minus y, and then we have minus, so minus sec square x minus y dy by dx. is equal to 0. Differentiation of 1 is 0. dy by dx, bring them together. So dy by dx, the sec square x plus y is there, and there is a negative sec square x minus y. So this already I have taken, that's why I am cancelling it. And whatever is left, just take it on the right hand side. So it will be, both will be in the negative. So I am taking the negative outside. It will be negative because both will be negative when they go on the right hand side. So negative I have taken, rest terms I have written. And dy by dx is simply division. Since we have a negative here, we can swap these terms on the left hand side. That is, in order to remove this negative, if you multiply both sides by negative, what will happen? The negative on the right side will go, but the terms will swap, negative positive on the left hand side. That we am bringing on the denominator. So it will be sec square x plus y, x minus y first, minus sec square x plus y. Okay. So this is going to be your final answer. So let's do it now, this one. So I'm doing the first one, that is, you have to prove dy by dx as there are two things they have asked. First thing and second thing is an equation, dy by dx plus e raised y minus x equals 0. So I'm doing the first one. I will encourage you to do the second part, or the way it can be achieved, the second answer. So I'm differentiating both sides. So e to the power x will always be e to the power x, e to the power y dy by dx, e to the power x plus y, again e to the power xy. The differentiation of x plus y is 1 plus dy by dx. Alright. Now multiply inside. You have e to the power x plus y plus e to the power x plus y dy by dx. Left you have e to the power x plus e to the power y dy by dx. And then bring these two together. So dy by dx, you have this e to the power y and minus e to the power x plus y. And then we have e to the power x plus y and minus e to the power x. Alright. So you can just bring it down in the denominator. E to the power x plus y minus e to the power x divided by e to the power y minus e to the power x plus y. Now this is the answer. But they have asked for certain solution that I am going to provide. This next solution, this will be left, I'll leave it for you. This is simple. You see, e to the power x plus y is simply written as e to the power x into e to the power y, because if the base is same, the power gets added. So e to the power x plus y is e to the power x into e to the power y. So e to the power x into e to the power y minus e to the power x, e raised y minus, here also e raised x into e raised y. Now e raised x you can take common, it will be 1 minus e to the power y minus 1, e to the power y from the denominator, 1 minus e to the power x. Now since the question is asking about the 1 minus ex in the denominator can be made as e to the power x minus 1 in order to match the question answer. So just take the negative outside, e to the power x by e to the power y. Numerator will remain like that, e to the power y minus 1, and since we have taken a negative outside, the denominator, the places can be changed. It will be e to the power x minus 1. Now if we have a cos y equals x cos a plus y, cos a cannot be equal to plus minus 1. We have to prove that dy by dx is equal to cos square a plus y by sin a. So we have seen a question like this where we don't have any x on the right hand side. So this x has to be substituted from the question being given. From this equation, if you compute x will be cos y. I am bringing this cos a plus y in the denominator. So this is going to be your x. Alright. And this sometime at some step we are going to substitute. Let us go to the normal way in we were solving. How we were solving? The left hand side, right hand side, left dy by dx, right other things. So cos y differentiation is minus sin y and then y is dy by dx. So x cos right hand side x cos a plus y. So we'll use the product rule. X dy by dx of cos a plus y, then plus cos a plus y, and d by dx of x, which is going to be 1. D by dx of x is 1. Okay. So we have x, and d by dx of cos a plus y is minus sin a plus y. And since we have a plus y also, so we have to take the differentiation of a plus y also. A is 0 because it is a constant, and y will be dy by dx. So this is going to be minus sin a plus y into dy by dx. So whole will be minus x sin a plus y and dy by dx. And this cos will be cos a plus y, and because cos a plus y we have already done the product rule. So minus sin dy by dx, so we will just combine this dy by dx together on one side. So when I take dy by dx on left hand side, just assume that we have this term already on the left hand side, so it will become positive, and this will become is equal to. So in one step only I am trying to explain. Alright, x sin a plus y, and from here it will be sin minus, it was so negative sin y. So we have x sin a plus y minus y on the left hand side with dy by dx. On right hand side we have this cos a plus y. Okay. Now this dy by dx, we are going to put this on the denominator, but still we have x. And when I started doing this question, I already told you that this x will replace. So cos a plus y will be on the right hand side, and this term which we are going to put in the denominator, I am replacing x by cos y by cos a plus y. So this is cos y by cos a plus y, and now this is sin a plus y, and this is minus sin y. I am doing this term, then we'll take it to the denominator. So let us take the LCM here. LCM is, you multiply the cross with the negative and divide by the multiplication of the denominator. So cos y sin a plus y minus sin y into cos a plus y, and divided by cos a plus y. Now this cos a plus y is in the denominator, and this will go in the denominator, remember. So this cos a plus y, when we'll bring it in the denominator of the denominator, it is going to go to the numerator. Just assume that the numerator is p and denominator is q. So p by q, when we'll put, q will go in the numerator, and q is of course cos a plus y only. So cos a plus y into cos a plus y will be cos square a plus y. Now we just have to deal with p. P is what? If I write it as sin a plus y cos y minus cos a plus y sin y. So this is sin a cos b minus cos a sin b. It's sin a minus b. Sin a plus y minus y, so y gets cancelled. You have a sin a in the denominator. So just put it here, sin a. So we have to prove, or we have proved dy by dx is this. Now we have, if sin square y plus cos xy is equal to k, find dy by dx at is x is equal to 1 and y is equal to pi by 4. We will do the differentiation and we'll put y as pi by 4 and x equals to 1. There is one more question coming, so just watch this question very carefully, because I'm going to leave that for you. Alright. So this sin squared y will be 2 sin y. Then the differentiation of sin y, which is going to be cos y, and differentiation of y is dy by dx. Next one is cos xy. Cos xy differentiation is minus sin xy. Then the differentiation of xy will be x dy by dx plus y d by dx of x, which is going to be 1. I am not writing it. So it will be sin xy into x dy by dx plus y. and this is equal to k. Differentiation of k is going to be constant, it is going to be 0. Now let us combine this dy by dx together. So you have 2 sin y cos y dy by dx minus sin xy, x sin xy, I am multiplying it, and xy dy by dx, and then minus y sin xy. This is going to be equal to 0. Now just combine this dy by dx and then find out the term 2 sin y cos y. So this 2 sin theta cos theta, actually it is 2 sin theta cos theta. So you can directly write it as sin 2 theta. Okay. So 2 sin y cos y is sin 2y. So I am writing it as sin 2y minus x sin x sin xy dy by dx. I have already taken common and bringing or transporting this on the right hand side, y sin xy. Now we can bring this down in the denominator, cross multiplication you can say. So this is sin 2y minus x sin xy in the denominator. So now we will put x as 1 and y is equal to pi by 4. X is 1, so wherever x is there you can just eliminate it. It's 1 only. Y will be pi by 4. So it is pi by 4 sin. X is going to be 1, y is pi by 4. So sin pi by 4. And sin, it's 45 degree. Sin twice of y, 2 into 45 is 90 degrees. So sin pi by 2 it is. So this is going to be sin 90. So let me write it as, this is sin 90. So I am writing it as 1, sin 90 is 1. And minus x is 1. Sin xy, so sin 1 sin 1 into pi by 4. Again sin pi by 4, sin pi by 4 is what? It's 1 by root 2. So write it as 1 by root 2. So pi by 4 is already there. Sin pi by 4 is 1 by root 2. So pi by 1, this pi by 4 into 1 by root 2, 1 by 1 minus root 2. So take the LCM in the denominator. 1 by root 2, it is going to be root 2 minus 1 by root 2. So you can just cancel this root 2. So it will be finally pi by 4, 1 by under root 2 minus 1. Or if you just want to write it the way the book has provided the answer, it's pi by 4 into under root 2 minus 1. Y is equal to log cos x sin x, log sin cos x inverse plus sin inverse 2x by 1 plus x square. And we have to find out dy by dx at x equal to pi by 4. So as I was discussing, this I am going to leave for you only the final step. The basic step I am going to do. That is, I am going to differentiate it properly. We'll do the differentiation and then whatever substitution is required, which is x equals to pi by 4, that will do. So let us see. This is all log. You have to have the knowledge of the logarithmic properties. Then you will be able to solve this properly. So log, if the base is say x and it is y, log base xy. So you can write, if it is minus 1, if it is the power y minus 1, this x and y can change the position. It is log x with the base y. So log cos and sine, I am writing it in short. So log base cos sine, and since we have this as inverse, we can just write it as log cos and sine will change the position, so it will be cos and sine. So they both are same, log cos x sin x, both are log cos x sin x. Base is cos x and we have sin x, so it is square of it. Now we cannot differentiate it now because the base is still something else. You have to convert this base into e. So log xy is log y by log x when the base will become e. So this log base cos and sine can be written as log sin x divided by log cos x. Now the base is e. Now we can start the differentiation. So basically it is square. Okay. Now let us differentiate the first part. Sine inverse 2x by 1 plus x square we'll take just now. First complete this one. So what is the differentiation? Anything with any power is, we consider is to be x to the power n, like x to the power n kind of thing. So x to the power n is n x to the power n minus 1. So this is going to be equal to twice of, just assume it to be p. I'm not going to write it again just to save the time and place. So if it is p, it is twice p. And d by dx of this p, this whole one. So if I have to do the differentiation of this is to be done using the quotient rule. It is a by b. A is log sin x, log cos x. If we assume it to be some p, which is actually a by b, we have to do it by the quotient rule. P is all of this. So I am going to differentiate it and then I am going to write it. So what is in the denominator? Log cos x whole square. This is your denominator. Log cos x will come here, and then differentiation of log sin x. Then subtraction minus log sin x and the d by dx of log cos x. Okay. So log cos x will remain like this, log cos x, and log sin x. Differentiation of log is 1 by that thing. So it will be 1 by sin x, and sin x differentiation is cos x. It is going to be cos x. Now minus log sin x. Let us write it like this. And I am not writing the denominator now, doing the numerator only. So d by dx of log cos x is 1 by cos x is minus sin x. So I am writing sin x here and changing the sign, negative to plus. So what it will be? Cos by sine and sin by cos. Cos by sine is cot, sin by cos is tan. So we have cot x log x plus this is tan x, so tan x log sin x. So what is up front? You have twice of p. P is what? I told you it is log sin x by log cos x. So when we write this log sin x by log cos x, and if you remember we have the denominator already. I didn't write the denominator just now. I am writing it because the denominator is log cos x whole square. So we have a log cos x square when we have log cos x also already there. So it will be q. So log cos x, this is the whole differentiation. This is the first part. We have already done the first part. That is the first term differentiation done. Now the second is sine inverse 2x divided by 1 plus x square differentiation. So this is going to be 1 by under root, whatever the content is there, and 1 by under root 1 minus square of that thing. So 1 by under root 1 minus 2x by 1 plus x whole square. Now differentiation of this internal term 2x by 1 plus x square. Okay. So this, let me just do it first. Then we'll do the differentiation here. So this is going to be, see, it is basically 1 minus 4x square by 1 plus x square. So let me write it here, 1 by under root 1 plus x whole square minus, or first let us square it, 1 minus 4x square by 1 plus x square. Now this is going to be 1 plus x, 1 by under root 1 plus x square and minus 4x square divided by under root 1 plus x square. And since it is in the under root and it is in the denominator, it will go up. So under root 1 plus x square whole square. So this will go in the numerator, and square, because it is square inside the under root, it will also get cancelled out. So what is the denominator? See, 1 plus x square is the numerator now. So whatever it is, this is nothing but this is 1 plus x square minus 2x whole square. So when you open it, you will get a formula. This is nothing but, I'll just show you. This is simple thing, 1 plus x, and this is not yet being solved because we just have to do 2x by 1 plus x square also. This we are going to do. So I'll just do this one and then I'll write the answer. So 1 plus x square divided by under root 1 plus x square minus 4x square. This is clear. Now differentiation of this is going to be 1 plus x square whole square in the denominator. 1 plus x square, then differentiation of twice of x will be 2 only, minus 2x will come in front, and differentiation of 1 plus x square will be 2x. So it is 2x. What did we get? It's twice of 1 plus x square minus 4x square. So there is a short of space I am having. So 2 plus 2x square minus 4x square, you get 2 minus 2x square, and 1 plus x square is already there in the denominator, 1 plus x square whole square. 1 plus x square whole square. So 1 minus x square by 1 plus x square. And what was there? 1 plus x square by 1 plus x square whole square. See, this is all 1 plus x square, and you can just change it, right? So under root, when you solve it, 1 plus x whole square minus 4x square, this is nothing but 1 minus x square whole square. This is nothing but this one only. 1 minus x square whole square. So since it is in the under root, only 1 minus x square will come. So 1 minus x square it is. So 1 minus x square gets cancelled. 1 plus x, one of the 1 plus x square whole square, one of these will cancel. So final will be only twice 2 by 1 plus x square. So this is the final result. So this is the final solution for the sin inverse 2x by 1 plus x square. So this one is the first solution. Let me remove it. I hope the differentiation is clear to you. So this is the final thing I have written. This we already got. So now, as the previous question we have done, which has just have to replace wherever x is this by pi by 4. Remember, pi by 4 is 45 degree. Sin 45, cos 45 is 1 by root 2, and tan 45 and cot 45 is 1. So this is the time I am leaving this question, because I hope you will be able to do it. The basic idea is to differentiate, which we have already done. Let me reiterate. Sin pi by 4, cos pi by 4 is 1 by root 2, and tan pi by 4 is 1. Okay. So this I hope you will be able to solve after this. This is your final. Just for your reference I have given. You can just match your result with this after you put x as pi by 4. Next one is this one. Under root y plus x plus under root y minus x is equal to c, constant. Show that this dy by dx is y by x minus under root y square by x square minus 1. So we'll do the differentiation, and see, under root of anything, for example, under root of p is 1 by twice of under root p, and differentiation p then. So 1 under root y plus x is 1 by twice of under root y plus x, and y plus x differentiation is what? Y plus x. This is going to be the differentiation. X is 1, y is dy by dx. So second one, under root y minus x is 1 by twice of under root y minus x, y is dy by dx, and differentiation of x is 1. And this is equal to the constant. Constant is, differentiation is 0. Okay, now multiply this, and then we'll take dy by dx on one side and others on other side. Now I just visualize and imagine that I've already multiplied this inside, and I am taking common dy by dx. So when we take dy by dx here, 1 by twice of under root y plus x will come. This one, when you multiply with dy by dx and take dy by dx common, what will be the result? 1 by twice of under root y minus x. What will be remaining? Already dy by dx is done, so multiplication of this with 1. And I am taking it on the right hand side also, and in the same step. So So this will be the first one will be negative when we take on the right hand side. So minus 1 by twice y under root y plus x. And this one, this is negative. So when it goes on the right hand side, it will be positive. So 1 by twice of under root y minus x. First we have to multiply and then take it on the right hand side. So 1 by twice of under root y minus x it will be. Now dy by dx and this. Are we able to resolve certain thing, cancel something? Yes. First thing is 2 in the denominator is everywhere seen. So you can just cancel these out. You can just take 2 common from both the sides and it will be a normal cancellation. Now I am taking the LCM here. Here also both sides I am taking. So simple under root y minus x plus under root y plus x divided by under root y plus x into under root y minus x. dy by dx is already there. What this will be? Under root y plus x minus under root y minus x divided by again under root y plus x into under root y minus x. This is clear? Now what do you see here? In the denominator, the terms are same. Denominator terms are same. So you can just cancel these two out. You can remove this because they are same. And now only the numerator of the left hand side remains, that can go in the denominator on the right hand side. So under root y plus x minus under root y minus x divided by under root y minus x plus under root y plus x. So we will rationalize it now. What is the rationalization? We always want the denominator to get resolved. So we have under root y. Since we have y plus x in the y plus x here, we can just change the position because plus, when it is plus, it doesn't matter. So we can just write it here as under root y plus x minus under root y minus x. Here also y plus x minus under root y minus x. Now this is a plus b, a minus b. A plus b into a minus b is a squared minus b squared. So it will be under root y plus x whole square and under root y minus x whole square. It will be y plus x minus y plus x. So it will be twice of x. So it will be twice of x in the denominator. And a minus b and a minus b. So the numerator will be a minus b whole square. A minus b whole square is a square plus b square minus 2ab. A square is, you can just remove the root. So y plus x plus y minus x minus twice of under root. So under root y plus x into y minus x will be a plus b into a minus b will be a square minus b square. So you can have y square under root y square minus x square. So under root y square minus x square. Now here 2x is already there in the denominator. X cancel. Y will be 2y minus twice of y square minus x square divided by 2x. Now you can just cancel this 2 to 2 because it can be taken common. So you have y minus under root y square minus x square divided by 2x. It is x because 2 has been cancelled. So how can we write? It is y by x minus. Now I am taking this x in the denominator, so it has to be x square. If I want to take in the denominator with an under root, x will be under root x square. It is actually equal to x only. So how can we write this? This is y by x already minus. Now this x square can again be taken in the denominator for both the terms in the numerator. So we have y square by x square minus x square by x square. So y square by x square minus 1. Y square by x square minus 1. And this is your final result, which was expected. This is your answer. Okay, this is all about this exercise. Thank you so much and take care of yourself.